Hello everyone, welcome to the channel TopGate. In this video, we'll see an example based on the semaphore variables. So in the previous lecture, we have seen what is a semaphore variable and we have seen how does a semaphore variable solves the critical section problem involving n number of processes. So in this one, we'll discuss one example based on the semaphore variables. So this question was asked in the GATE exam in 2020. So the question says that each of a set of n processes executes the following code using two semaphores. Two semaphore variables are there, A and B, and A has been initialized to 1, B has been initialized to 0. Further it says that assume that count is a shared variable initialized to 0 and not used in code section P. So we have the code here. In the code, we have the code section P, some kind of code is there in this code section P, and then we have all these statements, wait, A, count, and all those things, and then we have code section Q. And further, it is saying that what does the code achieve? And we have here 4 options. So we just have to find out of these 4 options, which option is correct. So first of all, we'll analyze that what this code is all about and what kind of operations are being performed in this code, and then we'll see that which option is the correct one. Okay, so this question is saying that we have n number of processes. So assume we have n is equal to 5. So we have 5 processes in the system. It can be anything. So we have taken as 5. So initially the number of processes that we have is 5. Then it is saying that we have 2 semaphore variables, A and B. So we have a semaphore variable as A, and it is saying that it has been initialized to 1. Done. And one more variable is there, that is B. It has been initialized to 0. And then it is saying that we have one more count variable. This count is a shared variable that can be shared among all the processes. If we have n is equal to 5, that means we have P1, P2, P3, P4, 5 processes, and all those 5 processes can share this count variable. So we have this count variable, and initially the value of count is set to 0. Okay, so we have this scenario right now, and we have this code here. So we'll see that one by one all the processes come P1, P2, P3, P4, and they all will execute all these statements in this code. Okay, so suppose P1 comes and P1 executes this code section P. It completes its work in code section P, comes out, and here it writes wait A. So wait A, we know that in wait A we have while A is less than or equal to 0, A is equal to A minus 1. So while A is less than or equal to 0, so it will check whether the value of A is less than or equal to 0. If it is less than or equal to 0, it will be stuck in the while loop. But it finds that the value of A is not either 0 or either less than or equal to 0. Therefore, that while loop is broken and it will execute the next statement of the wait operation. That is, A is equal to A minus 1. So the new value of A will be 0, and then it will execute this statement, count is equal to count plus 1. So initially the value of count was 0, now it will be count plus 1. That means the new value of count will be set to 1. Okay, then it will come here, it will execute if count is equal to n. It will check the value of count whether it is equal to 5 or not, because we have the value of n is equal to 5 right now. It will check whether the value of count is equal to 5 or not. No, the value of count is not equal to 5, it is 1 right now. Therefore, this statement will not be executed. It will come here. Here it will write signal A. Signal A means A is equal to A plus 1. So whatever in value you have decremented here in signal A, you will increment that value. So signal A means A is equal to A plus 1. So it was 0. Now the new value of A will be 1. Then it will execute wait B. Wait B means while B is less than or equal to 0, B is equal to B minus 1. So the value of B is equal to 0, therefore the condition is true, hence it will be stuck in the while loop. So the process P1 will be stuck here in the while loop. Okay, so P1 is stuck here in the while loop. Now process P2 comes. P2 also comes to the code section P, execute this code section P, again comes out, it will write wait A. Wait A means while A is less than or equal to 0, A is equal to A minus 1. So A is not equal to 0 right now. It is neither 0, it is nor less than 0, it is 1 right now. Therefore, that condition in the while loop is false and the while loop is broken. It will come out of the while loop and it will do a is equal to a minus 1. Again, the value of a will be changed from 1 to 0. Then it will write count is equal to count plus 1. So count was initially 1, which was set by process P1. Now it will be changed to 2. And then it will come out, here it will write if count is equal to n. Again it will check whether the value of count is equal to 5 or not. No, the value of count is not 5 right now, it is 2. Therefore, this statement is again not executed. It will come here, it will write signal A. Signal A means again the value of A was decremented here. Here it will be incremented. So new value of A will again be set to 1. And then it will write wait B. Wait B means while B is less than equal to 0, then only you have to execute the next statement. So B is equal to 0. Yes, the condition is true. Hence, this process P2 will also be stuck in the while loop. It will not be able to go to the next statement of the wait operation. It will be stuck here in the wait B part. So P2 also is stuck here. Similarly, P3 comes. P3 again makes the value of count is equal to 3. Again comes here, gets stuck here in the wait part. P4 comes, again increment the value of this count by 1, set it to 4, again come here and stuck here in the wait. So all those processes, if we have 5 processes, out of those 5 processes, 4 processes will be stuck here in the wait part. They won't be able to execute this statement because they are not finding the value of count is equal to 5. Now the last process P5 comes. P5 will come here. It will execute again the same thing. Everything will be executed. Here it will set the value of count is equal to count plus 1. That means the new value of count will be 5 now. This 5 is only for process P5. Now when the process P5 comes, it will execute this if count is equal to n. That is, if the value of count is equal to 5. Yes, the value of count is equal to 5. Therefore, for process P5 only, this operation will be executed. That is signal B. Signal B means B is equal to B plus 1. So the value of B was 0. Now it will be changed to 1. So as soon as the value of B changed to 1, now we have two options. First option, either this process P5 will execute this statement and then signal B and then go to code section Q, or other processes who were waiting in this part, wait B, they find the value of B is now not 0. The value of B is 1. So out of those process, any one process will be given the chance to execute this statement and then they will come to this code section Q. So one by one, all those processes will be able to break this part. They'll be able to break the while loop. They'll execute the next statement of the wait operation and then they'll execute the signal operation and then they will come here. Okay. So one thing is very clear from this code that unless and until every process executes this code section P, no process will be allowed to go to code section Q. Why? Because every process was stuck here in the wait part and they were not able to go to the code section Q unless and until the 5th process comes and increments this value by 1, then executes this statement signal B, then only all those processes will be given the chance to go to this code section Q. You can see the third option, that is, it ensures that no process executes code section Q before every process has finished code section P. That means every process has to complete code section P, then only every process can go to code section Q. No process can go to code section Q unless and until all the process complete their work in the code section P. So out of these 4, I suppose this one is the correct answer. Okay, now let's see, analyze all those options one by one. First option says that it ensures that at most 2 processes are in code section Q at any time. That means it is saying that this code ensures that at most 2 processes are in code section Q at any time. No, that is not the case. all those processes can go to code section Q. That means if we have 5 processes, all the 5 processes can go to code section Q at any time. There is no boundation such that only 2 processes are there in the code section Q. All those processes who are waiting here, when the 5th process execute this signal B statement, then all those processes can one by one go to code section Q. So this option is absolutely wrong option. Second one, it ensures that all processes execute code section P mutually exclusively. No, that is not true. Why? Because all the 5 processes can go to code section P. All those 5 processes can be there in the code section P at any moment of time. But yes, from this one, they will execute these statements one by one. Why? Because we have a lock mechanism here. That is, we have a wait and we have a signal. So this wait and signal means we have logged these codes here in this wait and signal, between this wait and signal. Clear? So all those processes can be there in the code section P at any time. But yes, one by one they will come out of the code section P. But no, it is saying that it is in the code section P, it should be mutually exclusively. No, it is not mutually exclusively. All the processes can be there in the code section P at any time. Therefore, this option is also the wrong option. Now let's see the fourth one. Fourth one says that it ensures that at most n-1 processes are in code section P at any time. No, again, we have seen this B option. It is saying that all those processes can be there in the code section P at any time. There is no such case that only n-1 processes can be there in this code section P. So this A, B and D options are the wrong options. The only correct option is the C option. It says that it ensures that no process executes code section Q before every process has finished code section P. So I hope this example is clear to you. Thank you so much.